Welcome back. And we are ready to kick off a new series. So, this is going to be a big series, just an FYI. For those of you who I would say probably started watching my channel a couple months ago or something like that, I introduced a library called Win32com. And pretty much out of all the series I think I've ever done, that was one of my more popular ones. That and along with the TD Ameritrade API. But the Win32com one really got people, I think, excited for a very, very simple reason, which was all of the sudden you had a library where you could access the Excel object model from Python. Now, a lot of people love Excel VBA, PowerPoint VBA, Word VBA, but now all of a sudden that you were able to take that same object model and leverage it in Python, it really kind of opened up like, wow, this is kind of neat. I mean, it really kind of opens the door to different types of things you can do and all the different types of problems that you might encounter. Because it was such a popular library, naturally, I kind of wanted to keep exploring this topic. And what I came across was another library called Pythonnet. Now, Pythonnet, in essence, is a library that will allow us to plug in to the .NET CLR. And so .NET is a very broad term at this stage. I'll just say that. There's a lot of different components of it, and there's a lot of different layers to it. But in essence, the Pythonnet library is just allowing us to plug into the CLR, which will then allow us to leverage libraries that were built in different languages. So in essence, there's a lot of similarities between Pythonnet and Win32com. Win32com allowed us to access COM object models. COM, I'm not going to say isn't used. It's an older technology, or it's an older kind of framework, and newer frameworks have come out, and you'll see that those frameworks are used more heavily than maybe COM. And so Pythonnet is really allowing us to leverage those new frameworks. And so what we're going to be able to do by the end of this is we're going to create our own Excel object model library. What do I mean by that? Basically, what we're going to be able to do is create an entire object library that would allow us to interact with the entire VBA object model using early binding. And you'll have things like IntelliSense. So when I hover over this, it says, oh, adds a new Excel workbook to the Excel workbooks collection. Oh, that's kind of neat. And oh, we can now change certain objects so that way we can customize them to do things like, oh, maybe I want to grab the active instance and I don't want to have to do all these crazy method calls and things like that. Maybe I just want to pass through a particular argument or something like that. That's what this is going to do. It's going to basically take Win32com to the next level. It's going to make it more intuitive. It's going to make it more customizable, and it's going to give you more control over using these libraries. And we're going to be able to expand into different types of libraries, not just VBA and stuff like that. We'll be able to plug into different types of data analytic libraries, internet libraries, being able to do things like connect to Wi-Fi, web scraping, being able to build user forms. Lots of really cool libraries will all of a sudden be available to us because of Pythonnet. But in order to fully understand Pythonnet, there's a lot that we have to kind of understand behind the scenes. But to give you just an idea of what this kind of script is going to do, all it's going to do is it's going to create a new instance of the Excel application. It's going to make sure we can see it. We're going to add a workbook. We're going to print those workbooks. We're going to get the count, and then we're going to print those names. So if I run this, praying there's no errors, we should see, look at that. And it gives you information as to what that particular object is. Look at that. So that means we have built really our first official library using Excel. How did I do it? Well, kind of complicated, but not too complicated. There's certain libraries inside of Pythonnet that will allow us to invoke certain methods and properties. And we can create all these class objects and do things like define the properties, define the methods, make sure that those methods return other objects, and just a lot of cool stuff. And really, I think the nice thing is I'm building our own little Win32com library. We'll be able to generate all of the files from a given assembly. I think this is the cool part personally. You can give me an assembly and I can build all the class object libraries from it. I can tell you the methods, I can tell you the properties, and I can make sure that they even will be assembled the correct way. There's obviously still more to do with this, but I've demonstrated it because I've built all these once and it took like 5 seconds, which is awesome. I think that is so cool. And so if you go into any of these ones, I mean, I don't know if this is the right one. You'll kind of see just the framework with them if they have methods and properties and things like that. But you can do things like the adjustments. So you'll see all the properties with them. Everything will be auto-generated and everything will be kind of lined up. But you can see the methods. It will set up everything so it calls those methods correctly. And what I'm trying to do next is being able to generate document strings that will be able to be inserted right here. So I think this is just super cool where we can now build our entire object library in early binding and then modify those files to, maybe improve upon them, whatever they might be, real time. So I just think this is just super cool. It's definitely been one of the more interesting libraries that I've worked with. So really interesting stuff coming up. So with that being said though, this video, there's not really going to be much coding. In fact, there's going to be no coding, but it's super important that you watch this video. If you're going to work with the Pythonnet library, you need to watch this video because we are going to be interacting heavily with the .NET framework, and you have to understand what that framework is. If you don't understand it, it's going to be really hard to understand what's going on behind the scenes, and you're not going to understand a lot of the jargon I'm throwing around. So the first section of this series is just what is .NET. So I built a little presentation. I'm going to get it ready, and then we can get started. Alrighty. First. All right, so I already told you Pythonnet is going to allow us to plug in to basically the .NET Framework CLR, or basically the .NET CLR. And with the CLR, we can interact with other objects that were built in different languages. It's basically going to make something language independent. That is a term that will come up heavily. Now, the CLR is part of something called .NET. .NET is a kind of umbrella term. If you want a really formal definition, I took exactly what was off Microsoft.com. So .NET is an open source developer platform created by Microsoft for building many different types of applications. With .NET, you can use multiple languages, editors, and libraries to build for web, mobile, desktop, gaming, and IoT. So high level, and I kind of put my notes on the right side because I think that's just kind of summarizing and probably not necessary. Again, it's open source, means anyone can use it. And more importantly, it's free. And then additionally, it's being used for a lot of different things. It's not just, writing a Python script and there you go. It's used for web, it's used for mobile, it's used for desktop, gaming, IoT. It's used for so many different things because it's basically Microsoft's entire development platform. And because Microsoft is so far reaching, I mean, you go on Xbox, you go on your laptop, you go on your phone, there's so much to it that it's really all encompassing. So there's a lot that goes with it. The important part is you also want to understand this is the highest level of the pyramid. Everything else comes below .NET. .NET is just a developer platform. It's just almost in a sense, I would call it an idea. It's kind of a place where you build things. There's different versions of .NET. There's not just a single .NET version. The one that we're going to be working with heavily is .NET Framework. So the .NET Framework is basically for Windows. That's how I would call it. It's the Windows version of .NET. There's .NET Core. .NET Core can be used on any operating system. You can use it on Mac. You can use it on Windows. I'm pretty sure you can use it on Linux. I'm not entirely sure, to be honest, but the idea behind .NET Core, you're getting the core functionality of .NET and you can use it anywhere. And then you have .NET Mono, and I don't know how to say the X one. Xamarin? I don't know. That one is for Mac. So this one will allow you to build on the Mac OS system. So important idea, there's not one single version of .NET. There's different versions of .NET, and each one of them is geared towards a different platform. What's the .NET framework? So .NET framework is the framework that provides the template for you to build the software. Again, mostly for the, it's basically just for Windows. But here, this is the framework. This is the template. This is the template you use to go and build your software. So whether that's a mobile app, maybe that's a desktop app, I don't care what it is, this is the template. How does it kind of do this template? Well, it provides you libraries, things like, hey, I will need a library to connect to the internet. I need a library that will help me web scrape. I need a library that will help me build user forms. It provides a bunch of different libraries that have these pre-built tools, and they help you do all these common things when you program. Things like, hey, I got to parse this string. I have to, I don't know, read an Excel file, something. It's taking all these common things that we have to do, and it's bundling all this functionality in different libraries, and it's putting them all in the same location. Why would you want to do this? It helps reduce development time. If I don't have to write everything from scratch, that saves me tons of time. I don't want to have to write everything from scratch. That's why it's beneficial to use .NET Framework. So all it's doing is bundling. It's taking pre-built tools, it's putting them all together, and it's providing you the templates necessary to go and develop what you need to develop in a reasonable amount of time. The biggest caveat, it's only available on Windows. And I have my little chart over here. You have .NET, you got the 3 different versions. We're gonna be working with .NET Framework. All right, so the .NET Framework has different components. What are the components? Well, there's 2 of them. The first one is the CLR, which is short for Common Language Runtime. And the other one is the .NET Framework Class Library. The Common Language Runtime is the execution engine. So this is the one that's executing and running your code. It handles all the complexities of running your code, memory management, garbage collection, type safety, exception handling. It does all the complicated stuff for you because it doesn't want you to have to worry about it. It just wants to make the development process easier. So when you think about this stuff, think about it. Why would they build this? They're trying to make the development process easier. So again, it's doing and handling a lot of the services for you behind the scenes. That's what the CLR is there for. The class library provides a set of APIs and types for common functionality. Remember those bundling of functionality that's already been done? That's what the class libraries are. So, hey, there's a class library for internet connection. Hey, there's a class library for forms. Hey, there's a class library for data things like, connecting to databases and things along that. So the class library is really, I would say, the templates in essence, and then the CLR is the actual service that it's providing. It's providing that runtime service. Oh, here we go. Fun. So the CLR, it's part of something bigger, right? The CLR is part of something called the CLI. Well, what's the CLI? The CLI is short for Common Language Infrastructure. Infrastructure is a key word here, and is a standard developed by Microsoft that allows the use of multiple different high-level languages on different computer platforms without rewriting the code for any specific architecture. That's really important. All compatible languages compile to Common Intermediate Language, CIL, which is an intermediate language. When the code is executed, the platform-specific VES will compile the CIL to the machine language according to the specific hardware and operating systems. Again, all these definitions are coming right from Microsoft. I just kind of add a little bit of fluff to them. We need a standard. Think about that for a second. How do I make something language independent? So for example, we use VBA a lot. How do I write it in VBA using Python? How do I write something in Python using a VBA? How do I write something in C# using an F#? The infrastructure sets the standard. It sets the rules. It says you got to follow X, Y, Z if you want to be part of this infrastructure. Yeah, makes it maybe a little bit more complicated, but there's a benefit. You can use it anywhere. Want to write in F#? Go right ahead. Want to go write in C#? Go ahead. No problem. Use it. But you got to follow the rules. What are some of the rules? Common type system. Yeah, I'll do the full definition. So the common type system defines the programming types and operations supported by .NET Runtime Engine. It defines the rules that the language must follow, which helps ensure that the objects written in different languages can interact with each other. It defines the rules that ensure that the data types of objects written in various can interact with each other. It's the rule. If I write it in one type, I have to make sure I can interpret that type. That's the important part. It's defining the rules. Metadata. It describes all classes and class members that are defined in the assembly, and the classes and class members that the current assembly will call from another assembly. A CLI language compiler will generate the metadata and store this in the assembly containing the CIL. Basically, think about it like this. You're giving somebody a cookbook. You're saying, hey, I'm going to be using this. I'm going to be using that. I'm going to be using this. I'm going to be over here. And this is how that little thing works. It's an instruction manual. It's telling you how this thing works, where it exists, and which other things it's going to be calling. The metadata is the instruction manual. Common language specification. For programming language to communicate effectively, targeting CLI is not enough. There must be a common set of standards to which every .NET language must adhere. This common set of language features is called the common language specification. Again, this is just kind of defining, how you kind of define your programming language as a whole, but it's basically just defining the specifications. There's a lot to it. I don't want to go into that much detail, but just understand it's another way of defining a standard. Then we have our virtual execution system. The VES is responsible for loading and executing programs that are written for the .NET runtime. The purpose of the VES is to provide support that is required to execute the common intermediate language instruction set. Okay, I write the standard, I compile it to CIL, I need something to run it. That's the virtual execution system. It takes that intermediate language and it helps execute it. It's going to help follow the instructions that were written in essence. All right. So how do we visualize this big picture, right? How do we visualize it? Well, .NET, there's a lot of different, I would say, languages that kind of go with it. There's VB.NET, so Visual Basic .NET. You have C#, you have F#. I really don't know. I don't think Q# would be part of it yet. Maybe it kind of is. I'll leave it out. There's another language called Q#, and that's Microsoft's one for quantum computing, but it uses C#. So I don't know how this would technically fit in here, but I'm just going to assume it's not part of it. But basically, the idea is simple. Code it. If you want to code it in VB.NET, you go right ahead. You want to code it in C#, go right ahead. F#, go for it. Compile it. So you compile it to however you want, but you're going to compile it to the common language infrastructure standards. So when you compile it, you're going to follow this standard. When you follow that standard, what are we going to do? We're going to standardize it. We're going to standardize it by compiling it to the common intermediate language. So now it's not C#, now it's not F#, now it's not VB.NET, it's just CIL. It's a CIL, and now you've standardized it. It's now language independent. You're not anything unique, you're all standardized. Then you run it. So you use the CLR, the common language runtime, to run the standardized code. And then that's kind of where you're supposed to see like the 0, 1, 0, all that stuff. So now you're running it. So this is the big picture. You code it, you compile it, you standardize it, you run it. Ooh, fun. So what is CIL? Well, again, definitions. What is intermediate language, or IL for short? It is a product of compilation of code written in high-level .NET languages. Once you compile your code written in one of these languages, you will get a binary that is made from IL. It is important to note that the IL is independent from any specific language. You just wrote something in one language, guess what? You took away its individual identity. You just made it independent. So, is independent from any specific language that runs on top of the runtime. There is even separate specifications for it that you can read if you're so inclined. I mean, I'm serious, like there's tons of documentation. I mean, it's like literally a book. So don't ever feel like there's not enough documentation. Once you produce IL from your high-level code, you will most likely just want to run it. I wrote all this code and there we go. I went too far ahead. So you're just going to want to run it. So this is where the CLR takes over. You compiled your code. We need to run your code. The CLR takes over and starts the process of the just-in-time compiling, or JIT-ing your code from IL to machine code that can be run on a CPO. In this way, the CLR knows exactly what your code is doing and can effectively manage it. Intermediate language is also called CIL, Common Intermediate Language, or Microsoft Intermediate Language, because Microsoft is the one that basically developed it. Just-in-time compiling. It's a little bit, I mean, it's not deceiving, but just in time. I'm literally waiting until I have to run the code to compile it. So just in time to convert it from IL to machine code. That's kind of how I like to think about it. CLR. So the .NET framework provides a runtime environment called the Common Language Runtime, which runs the code and provides the services that make development process easier. Guess what? This is where we plug into from Pythonnet. Pythonnet, you plug into the CLR. Compilers and tools expose the Common Language Runtime's functionality and enable you to write code that benefits from this managed execution environment. They handle all the fun services for you. Great, I don't have to worry about it. Code that you develop with the language compiler that targets the runtime is called managed code. It benefits from features such as cross-language integration, cross-language exception handling, enhanced security, versioning, and deployment support, a simplified model for component interaction and debugging in profiling services. Basically, what Microsoft is doing is saying, hey, you follow our standards, we're going to handle all these services for you. So that's the incentive. That's why you want to write your code so it can basically be used across languages and things like that. And so if you target this runtime, okay, you're going to be able to get all these extra services. Wonderful. Okay, so CLR, that was the first big component of .NET framework, right? Now we're on the second component. What are class libraries? Well, remember, the class library stuff, that's the templates in a sense, right? That's the tools that are pre-built for you and you don't have to rewrite everything, but there's different categories of libraries. There's not just one library. The first one is the standard class library. Now, for each one of these, I try to put it in more simplified terms. For a standard class library, I can use the entire library on any platform. I can use it anywhere. Because it's standardized, it can be used on any of the platforms for basically .NET Core, right? So imagine I was using .NET Core on any of my platforms. I can use the standard class library anywhere. I can use it anywhere. Then we get to the very specific ones, platform-specific libraries. I can use all of it only on a specific platform. What that means is maybe I have Excel, maybe not Excel interrupt, but there are certain Windows API libraries, right? If they're Windows API library, they only work for Windows. So I can use all of the functionality in that library on Windows, but the minute I try to go over to Mac, good luck, it ain't gonna work. Then you have portable class libraries. This is kind of the in-between. Well, you can use part of it somewhere, but then you can use part of it anywhere. So some of it is very restricted and can only be used on that particular platform. And then the other portion of it can be used on any of the platforms. It doesn't matter. Just, you want to use it on Mac, go for it. You want to use it on Windows, go for it. But this is what I call the hybrid. It's not one or the other. It's kind of the in-between, and it's kind of the mixed, component. It's not A or B. It's kind of in between. So that's what the class libraries are. And with that being said, and my voice is slowly going away, I don't know what happens. Every time I do this, it just goes away. But with that being said, I think you have enough of a foundation to start looking into Pythonnet. But you really should not be going into Pythonnet unless you understand what .NET is and really what was it designed for? What is it trying to do? And why would we even want to work with this? And once you understand those core features and you understand the big picture behind it, you can understand why we're able to do what we do. And you're really able to understand why it works the way it works. It's there to make our lives easier. It's there to make interacting with these different objects easier. And it doesn't mean it's perfect, and it doesn't mean you're going to go right into Pythonnet and go like, oh, this is great. There's definitely some challenges along the way. But part of overcoming those challenges is understanding how they work and understanding how we can get by them. So to kind of, I guess, give you context, initially when I first tried using Excel in the Pythonnet library, I couldn't. There were all sorts of errors. There were all sorts of things where it couldn't understand what the object I was working with. And basically, when I went online, I found out, well, there's really just nothing you can do about it. I mean, well, you can do something about it, but it's this really roundabout way. And I'm like, nobody is ever going to want to work with this library if you have to literally write it like this. It's just, nobody's going to want to do it, especially people who use Python. People who use Python are just used to having things easy. I'm used to, well, I use Python a lot, so I'm just used to libraries being like very intuitive and straightforward and not having to write too much code. And so when I initially looked at it, I said, there's got to be a better way of doing this. And a lot of it was exploring, a lot of it was testing. I said, there totally is. We can just write our own library that taps into that same object model, but leverages the CLR, but not even that much. It's not even leveraging it that much. And what we were able to do is now create something that I think is 10 times easier to use, because normally, if you wanted to do any of this stuff, every time you would want to invoke something, you would have to use this beast. You'd have to run all this stuff. You'd have to know the method, if it was a method, if it was a property, you'd have to know the arguments, the argument types, any of that stuff. That just bogs down the development time, and it makes working with these libraries not super friendly. What I'm trying to do is take that all away. If you want to call a method, just call a method. If you want to pass through an argument the way you're used to passing it through. Don't worry about the, I would say, finer details behind the scenes. But when you do this, you're able to make these libraries easier to work with, but you're also able to incorporate a ton of new functionality that you normally didn't have. So that's why I think this library is so cool, but you also have to understand how it's doing it and why we have to use certain libraries. So, sorry for ranting, but I think it's good to have that context. With that being said, thank you again for watching, everybody. In our next video, we will kick off Pythonnet and start the coding fun, right? That's where the fun begins. And then from there, we'll start working with a couple libraries, and then we'll start building this wonderful Excel object model. So thank you again for watching, everybody. We will see you in the next video.